Guys, so here I want to show you guys how to use this amazing applet, and I have linked for the website that you can use to simulate electrical circuits. Like for example, in class 2 we did a lot of things about related to batteries and buzzers and electric bulbs and things like that. And I just want to use this app or this website to answer a few questions from the second lab so that you can both understand the concepts related to the second class and how to use this website. So if you're on your Canvas page, if you go to home, and the second block here is videos slash simulations, and the second one is virtual circuit constructions. You click on it and then it will ask you, like, will show you the option to again click on this box which turns black, and if you click on it, it will open the web page. Wait a second for it to load, and then you will have this window in front of you. Make sure before you start doing anything, you click on right here where it says show current. Make sure it's clicked, and then instead of electrons, click or select conventional. You will understand later why I'm making you do this, but for now just make sure you do that. On the right hand side for class 2, only what you have to know is that this device you see on the right hand side is called ammeter, and this measures current in the wire. So you will see that current is basically the flow or the flow rate in a wire. So the same way you have flow rates in siphon, or whenever you have things which are flowing in a pipe, for example, you have got flow rate. So the analogy is that the same as flow rate, you've got current, and so to measure that current you need ammeter, and I'll show you how to use it. So we have this. Let's first start with constructing these circuits. So you see three circuits here, A, B, and C. And there are a series of questions related to this which we can figure out by making the circuit. So it says question 21, in circuit A, how does the circuit in light bulb 1 compare to the current in light bulb 2? So the idea is the brighter the light bulb will glow, the higher the current is going through it. Okay, so that's the relation. So let's see. So we're going to make this circuit. So we have one battery here and two bulbs, right? So I go here and I say, okay, I need one battery, and I've got one battery, and then as you can see, this battery's positive terminal goes into the one of the wires in bulb 1. So I need a wire. So I take one wire and I do that. Okay. So this wire goes in the first bulb. So I have my bulb here. The second wire comes out and goes into the second bulb. So I do that. So I need one more wire, goes into the second bulb. So I just drag and place it here. The wire coming out of the second bulb goes back into the battery. So I need this wire, and also I can make this wire bigger like that, and I just need one more wire. Let's see, that works. Awesome. So you see, like, it really shows you the analogy that we were trying to make of this this fluid, like water flowing in pipes, like in a siphon system with current, or we were calling it electricity flowing through the wire. So as you can see here, from the positive terminal, the current comes in, goes through bulb 1, then goes through second bulb, goes back into the battery. So this is really nice if you're at home and you want to practice for your exam and things like that. You can simulate whatever we did in the class. Okay, so as you can see right now, you can't really tell what is the current in the in bulb 1 or bulb 2, right? So that cannot be like really that cannot be showed at this point. But if you come here, you need to know what is the brightness compared, or the current compared to light bulb 1 and light bulb 2. So as I said, we're going to use ammeter for this case. So if you single click on any of this node, these nodes, these connections, as you can see, this scissor icon pops up. So what that means is that you can, if you click on that, that breaks the connection. So you can insert something else. So I'm going to do exactly that. Let me make the circuit bigger so that I can place my ammeters in there so that we can measure current. So I'm going to take this one out and place it here. Awesome. See, okay, so it tells me the current through bulb 1 is 0.5 amperes. That big letter, big A you see, that is amperes. That is the unit of current. So for example, everything in physics except numbers, like things like weight, mass, velocity, current, these things, they have units. So the unit of current is ampere. So you see it's 0.45 amperes. So I use that one single ammeter to see what is the current going through bulb 1, but I can use another ammeter. So I just need to insert at this node, and then you can play around and really find out what's going on by yourself. I'm going to use this one, break this right here, drag and drop another ammeter here, make sure the connection sticks, and as you can see, both of these currents going through bulb 1 and bulb 2, they are the same, and they are 0.45 amperes. So the answer for question number 21 would be the current through bulb 1 is the same as current through bulb 2. I'm going to do one more quickly. You get the gist. I mean, you can just make any circuit and answer these kind of questions. So let me just do 3 and 4, or maybe I should do, let's do this one. How does the current in light bulb 4 compares to the current in light bulb 5? Okay, so we're going to make two more circuits, B and C. So for circuit B, I've got 2 batteries and 2 bulbs, and all I need to do is just add one more battery to circuit A and I will get circuit B. So let's just do that. I'm going to break this connection right here because I need to add one more battery here. Pick this battery. Make sure the positive end goes into the negative end of the first battery. Swing that back here, and there you go. So the first thing we see is that the bulbs are shining brighter, which makes sense because now there are 2 batteries instead of 1. So if we really want to see the analogy, it's like as increasing the height of the siphons, and because you will increase the height of the siphons, you will also increase the flow. The same way, if you double the size of the battery or increase the size of the battery by having 2 batteries instead of 1, as you can see, the current goes up and it is 0.90 ampere. And it is interesting that you double the battery, so the current doubles too. It's pretty much saying as if you increase the height difference to 2 times, the flow will also increase by 2 times. So that is the second circuit, and as you can see, the current through bulb 3 and bulb 4, now these bulbs are 3 and 4, not A and B, not 1 and 2, because this is the second circuit, circuit B. So you've got 3 and 4. As you can see, the currents are the same through 3 and 4. Let's make another circuit right here. So I'll need 2 batteries, and now the circuit is, I'm trying to make circuit C. The circuit is C, then a bulb, then a battery, and then another bulb. So circuit C, so I need a battery, let me use a wire, light bulb, let me use more wire, and another battery, okay, more wire, light bulb, and more wire, and then just use one more. Ta-da! See, it's working. Amazing. So just by looking at it, you can see that okay, and the brightness in these bulbs, these four bulbs, they are about the same. But really, to know the values of the current, we'll need ammeter. So I'm going to do the same thing. I'm going to just, like, let's say, cut the connection right here so that I can insert my ammeter. All right, done. Let's do the same here. My ammeter goes here. Done. As you can see, so on the left you have got circuit B, on the right you've got circuit C, and as you can see, the currents are the same. So the idea is, if you have two electrical components, like for example, which are like taking in the power from the battery power will get distributed among these two uh, electrical components, which are bulbs here. So they are getting distributed in different ways, but they are equally getting distributed. That's why the current through bulb, like these bulbs in circuit B, is same as the current through these bulbs. So the answer to question, how does the current in light bulb 4 compare to the current in light bulb 5, so 4 here and 5 here, the answer is the current will be the same. So that is how you can use this website here, which is linked in Canvas, to really play around with any circuit you can imagine, and you can answer different questions. You can do, for example, question 2, where you make these circuits and then answer these questions.